What up, mathletes? Whoop, whoop. All right, this is 4.5 arithmetic sequences. I will write and graph equations of arithmetic sequences as your learning target. Please go ahead for the warm-up. Find the next three terms in each pattern. Pause this. I'm going to take a sip of coffee, and then we're going to get on it. Ready, set, go. Okay. So let's find the pattern. This is minus or plus 3, minus 1, plus 3, minus 1, looks like a pattern, plus 3, minus 1, plus 3, so it's going to be minus 1, should go to 3, then it's going to go plus 3 again, which is 6, then it's going to go minus 1, which is 5. Boom. For number 2, let's see, plus 1, plus 2, plus 3, how many goes plus 4, plus 5, okay, there we go. So then, should be plus 6, which is 21, plus 7, which is 28, plus 8, which is 36. There we go. This one's a little different. I recognize it for what it is. It's going to be a plus 1 squared, a plus 2 squared, which is 4, a plus 3 squared, which is 9, so a plus 4 squared, which is going to be a plus 16, a plus 5 squared, which is going to be a plus 25. Oh, you can't see that, sorry. And then a plus 6 squared, which is a plus 36. Those ones used to stump me, but I've started to recognize them in my later years. Okay, and then one last one. Let's see, this is going to go 3, 4, 5, and this is 1, 2, 3. So this is going to 3, 4, 5, 60. Leave some room, 7D, leave some room, 8D. And then this is 1, 2, 3, minus 4, minus 5, minus 6. You do enough of these, you start to see those patterns. All right, I've got some vocab. You can see mine right here, but I'll show you probably a much better representation of it right here. Whoa, that got weird for a second. Let's make this full screen. Okay, take a minute, write it down. Sequence, a list of numbers in a specific order. Term of a sequence, a number in a sequence. It's one of the terms, right? Arithmetic sequence is a pattern in which each term after the first is by adding a constant, the common difference d, to the previous term. And the common difference is the difference between consecutive terms in an arithmetic sequence. Pause this, write it down, because we're going to get rolling right away. Ready, set, go. All right. So let's go to the next slide here. Okay, we can look at the sequence of this row. Notice that in row 1, right here, 1, 2, 3, 4, 5, 6, there's 7. Row 2, there's 9. Row 3, there's 11. Row 4, there's 13. That is a sequence. It goes from 7 plus 2 to 9 plus 2 to 11 plus 11 to 13. It's called an arithmetic sequence because the common difference is plus 2. You got to indicate whether it's plus or minus for sequences. So let's look down here. Go ahead and write this down, these words, and write down these examples. It says an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. So you can see 22 to 17 is minus 5, 17 to 12 is minus 5, minus 5, minus 5. The common difference is minus 5. In the same way, negative 13 to negative 5 is plus 8, to 3 is plus 8, to 11 is plus 8. The common difference is plus 8. Again, take a minute. I'll sip my coffee. Pause it, write it down. And I'll take off these sticky notes that I had placed to cover stuff up. And let's go. I'm just going to walk you through this example a little bit so you can see what's going on. Okay, determine whether each sequence is an arithmetic sequence. Justify your reasoning. First, we got to check the distance between them, or the difference between them. We're going to have -3, -4. Is that the same? We see there's a pattern here. There's clearly a pattern, but it is not the same. It has to be a common difference. There can be a pattern. This can still have a pattern to it, but it is not an arithmetic sequence. So because of that, it's not constant, not an arithmetic sequence. Let's look at this next one. This one looks ugly. Let's find out. +3/4, +3/4, +3/4. Turns out +3/4 because 6/4 is 3/2. This one is an arithmetic sequence because it has a common difference. Doesn't matter if they look ugly or fractional, it is good. Okay, so now we're going to go back to our paper. Got that all filled in. And we're going to do our own example. So I want you guys to look here. Determine whether each sequence is an arithmetic sequence. Justify your reasoning. Let's look at this. -1, -2, -4, -8. What do you think? Well, let's look. Notice that it's a -1, -2, -4. That's not an arithmetic sequence because it has no common difference. I just use CD for common difference. How about 0, 1, 4, 9, 16? I show it right here as being +1, +3, +5, +17. It really is just 1 squared, 2 squared, 3 squared, 4 squared. But at the end of the day, again, same. I just put same. Not a common difference. Not an arithmetic sequence. How about this one right here? Well, let's see. To get from -5.25 to 1 is 6.25. Plus 6.25 is 7.25. Plus 6.25 is 13.5. Yes, that is a sequence because there's a common difference of plus 6.25. All right, take a minute. I'm going to pause it, find the next 4 terms of the arithmetic sequence, 18, 11, 4, -3. Ready, set, go. Famous coffee sip. Perfect. Well, what do we have right here? This is a common difference of -7. So -7 is going to be -10, -17, -24, -31. All right. That's it for today. We're just keeping it simple. With that said, peace out.